So, we're all getting pretty comfortable with our own personal AI assistants, right? But what happens when they start talking to each other? What happens when you unleash not just one AI, but an entire swarm of them? Today, we're going to dig into a hidden and, frankly, exponential danger lurking in these multi-agent AI systems and talk about how we can finally start to measure it.
I want you to just let this quote from Tiberio Caetano sink in for a second. It absolutely nails the paradox we're facing. You can test every single AI agent you have one by one and prove that each is perfectly safe, totally reliable. But the moment you let them interact, a whole new, completely unpredictable kind of risk just emerges from the chaos.
So let's get into it. How does this risk actually build up? Well, it's because the entire rulebook gets thrown out the window when you go from a single AI to a whole team of them. This isn't just, more of the same. It's a completely different beast. And this slide right here lays it all out perfectly. Think about a single agent. The risk is pretty linear, right? You add a feature, you add a predictable little bit of risk. It's additive. But with a whole swarm of agents? Oh no, the risk becomes combinatorial. It just explodes. It's not 1 + 1 = 2 anymore. It's one agent interacting with another, which interacts with another, creating just this web of unforeseen possibilities. And while this AI agent technology feels so cutting edge and new, the fundamental problem, this pattern of automated systems creating total unforeseen chaos, it's not new at all. We've actually seen previews of this movie before, and each time, the stakes just get higher and higher.
Let's just walk through this timeline because it really shows you the escalation. Back in 2010, you had the flash crash. That was caused by pretty simple trading agents interacting in ways nobody saw coming, wiping out $1 trillion. $1 trillion. Then, jump to 2016. You have Microsoft's Tay, which showed how even a single agent can be corrupted by a bad feedback loop. By 2023, with things like AutoGPT, we were seeing agents getting themselves stuck in infinite loops all on their own. And now, looking ahead, agents are making the leap from just generating text to actually taking actions on a computer. The potential for real damage is becoming incredibly real.
Okay, so that brings us to the nitty-gritty. What are the specific ways these systems can blow up in our faces? It's one thing to talk about risk in the abstract, but it's a whole other thing to look at the exact failure modes that are giving developers and, frankly, CEOs nightmares.
These are pretty much the 5 big ones. Miscoordination, goal conflict, those are kind of straightforward. But then you get the really sneaky ones, like emergent collusion, where agents find some clever loophole to work together on something harmful you never ever intended. Or hallucination cascades. That's where one agent makes one tiny little error and the rest of the swarm picks it up and just amplifies it into a massive problem. And of course, the classic infinite loops, which can just burn through your resources in seconds.
All right, to make this painfully real, let's walk through a simple and honestly terrifyingly plausible scenario. This is a perfect example of how two individually good agents can team up to create a very bad day. Okay, so first up, we've got our inventory agent. Its whole job is to watch the warehouse stock. It sees you're running low on a popular product, and doing its job perfectly, it fires off a request to order more. So far, so good. Simple, logical, totally correct. Next, we have the purchasing agent. It sees the request come in. It also does its job perfectly. It places the order with the supplier. But, and here's the tiny glitch that's about to cause a disaster. The supplier's system is a little slow, and the confirmation message back to our system gets delayed.
And boom, there it is, the disaster. Because that confirmation was delayed, the inventory agent checks the stock again, sees it's still low, and what does it do? It correctly concludes, we need to place another order. And then another, and another. You see where this is going? Two individually smart agents just created an infinite feedback loop that could literally bankrupt a company in a matter of hours.
And hey, this isn't just some hypothetical like cooked up. As Lewis Hammond from the Cooperative AI Foundation points out, these errors can compound disastrously. They even have a name for it: cascading policy corruption. And that's exactly what we just witnessed. One small system delay corrupted the entire policy, leading to chaos. Okay. So we've seen the chaos, we get the problem. The really critical question now becomes, can we actually get ahead of this? Can we move from just reacting to these messes to actually calculating the risk before we hit deploy? I mean, seriously, how do you put a number on something that feels so random? How do you quantify the odds of one of these cascading failures happening before you've even let the system run?
Well, this is the proposed answer, a tool that's designed to do just that, to quantify that exponential risk.
The goal is super simple. Take all those abstract fears about collusion and infinite loops and turn them into a single, concrete score you can actually see and work with. And it works by looking at three core things that really control the risk level. First, autonomy level. How much freedom do your agents have to just go off and do things on their own? Second, tool access. What can they actually do? Can they spend money? Can they access sensitive customer data? And third, human oversight. How much is a person involved? Are they in the loop, approving every big decision, or are they just kind of watching from the sidelines?
So what's the point of all this? What do you get? Well, the true power isn't just knowing the risk score yourself. It's about being able to communicate it. This whole thing is designed to turn the black box of agent chaos into a clear, understandable benchmark.
And this is what you get as an output. It's not some dense academic report, it's a simple, intuitive risk score. Red, yellow, green. It's something a developer, a product manager, and a CEO can all look at together and instantly get on the same page.
This is so important because it creates a shared language for talking about risk. For what feels like the first time, the tech teams have a standard metric they can bring to the C-suite, to the compliance folks, to any stakeholder really, and have a real data-driven conversation about AI safety.
So look, we've laid out all the dangers, from historical market crashes to those scary feedback loops. We know for a fact that a collection of safe agents does not make for a safe system. So the only real question left is, are you ready to stop just guessing and start actually quantifying your risk?